Yeah, so I think differently, but where I think I said that you give it for machine learning, it learns the rules by itself, right? So you give it the data and then the label. The label is the working, the running, whatever. So it will learn from that data and then it will pick out some pattern within each label and then it will be able to predict in the future, right? So it means that the next, so for the machine learning paradigm, right? So first of all, you have to make a guess, obviously, because once you start to train your network, it doesn't know anything, right? So the network or the model you design will have to make a guess first. So it will make a guess, then it will measure the accuracy, like how accurate it is, right? And then it will optimize the guess, and then it will repeat again. So it does this for a number of times before it gets it right. Then you can say that your model has been trained. Understood?
Yes, sir.
Yeah.
So,
So,
sir,
yeah.
after it measured your accuracy, and then the accuracy doesn't add up to, will it alert you to make a different
Right.
guess?
So what happens normally is that you design a network and then automatically it will now start to train itself. So it will train and train and train. And then after that, after training, it will give you the accuracy. So it says, oh, after training for like 100, 200 times, this is the accuracy you get. You get 80% or 90% or something. So now, based on what you want, probably that accuracy is not enough for you. Like, or it's too, probably, if you get an accuracy of, let's say, 40%, you know that your model is it's not really good, right? So you will now have to now go and change what you have designed, change something about the design, probably add more neurons or remove some neurons and do all that, and now train it again. So it trains and gives you the accuracy, and then you now decide whether the accuracy is good for you or not. If it's good for you, then fine. If it's not good for you, you have to go back and change the network again, and now and train again. That's how it is done. Right? So now after it has trained and everything, it gets the rules. That's what I was talking about. It gets the rules, and then from there, after you have trained it, you all you do is infer, right? Inference. So in the inference stage, all you do is you give it data and then it predicts. You don't train it anymore. You just give it the data and then it will predict what that data is about for you, right? So if you take an example like this, so even in the first place, I said that for traditional coding, like how you code, yeah, probably C, C++, and stuff like that, you have the rules. You have to hard code the rules itself, right? And then you give it the data, and then it gives you answers, right? So probably if you have something like an input of X, and I want to match X to some values, so I give it an input X, right? And then I have Y is equals to P times X plus B, right? So Y is my output, or Y is the answers I want, right? So now, and then X is my input. So it's Y is equal to what? P times what? X, right? Plus B. So this is my input, right? Now, if I if I want to get answers for this one, right? In normal kind of in the normal sense, I have to hard code this P and B, right? Because I don't know P and B. If I don't know P and B, I can't get any answer. So in normal coding, you have to hard code it. Int P is equal to some number. Uh, int B is equal to the number. So then after that, if I give it X, then it can actually calculate and give it me some value. You understand? So I have to hard code the P. So the P and B are the rules. So it's the rules you hard code in your program. Then you give it the X and then it gives answers. This is the way normal things happen, right? But in machine learning, you have Y, you have X, and you don't know P and B. You want the system to learn the P and B by itself. Understood?
So, in this case, you input your the P and the B for
Yeah.
the machine to learn.
No, no, you
You for
just
the
you so here, so
so
for the
let's say the
tradition,
X is the input.
yeah, X in the
So it means that if you give the X as an input data to the
to the
machine,
machine, and then you give it an answer.
then you give it an
So
answer.
because here we want to match what we want to do. Essentially, what we want to do is that we have some values of X.
Okay.
We want to match those values to some values of Y. So if x is minus 1, right? Y is minus 3. Have you seen it on the body? So if x is 0, y is minus 1. If x is 1, y is 1. If x is 2, so this some kind of, so we have the data and then we have the answers, right? So this is what we want to do. And I'm saying that for traditional coding style, right, to find to find the P and B, right? Here you can just match y is equal to 2x minus 1. So P is 2. This P is 2, right? This the B is minus 1. So in programming, in normal sense, you have to hard code these values, this P and B, so that the system can get the answers for you. But in the machine learning, you don't have to do that, right? So you want the system to learn the P and then the B by itself. So let's see how we are going to do that. So and then it is very easy. It's very easy. Like how they do is very easy. So like we want to match X to some Y, right? So we have our X is over there, which is our inputs or our data. Our Y are the answers or the labels, right? And then we have Y is equal to this is the equation. But we want the system to learn P and B by itself. So we can do it on our own. Right? So how do we go about doing it? How do you do it? Who knows?
But the formula, we are good with it.
So now we have P is equal to Y is equal to P times X plus B, right? So now how do we find P and B in terms of machine learning? P and B, yeah. How do we find P and B?
In case of machine learning.
Yeah, yeah, yeah. So you see that at first I said what we're doing is that you make a guess. You remember that part, right?
It makes sense. Then you look at
So
the
here you make a guess of P and B. That's all it does. It just makes a guess. Okay, let me guess P and B values. And then it feeds the X value to it. And then it gets an answer, right? It compares that answer to the right answer. Is it correct or wrong? If it's wrong, then I have to go and adjust the P and B again. Then do it separate. So you see how easy that is. So it does it over and over and over until it learns the right value, until it gets the right accuracy. The accuracy is good for it. That's how machine learning is. That as simple as that. And and it works every time.
it works.
It works every time, right? Because it is not you doing. You see,
Keep guessing the values.
the fact is that
Until
yeah, until you get the highest accuracy.
the high values.
And then it is not you doing it, right? It's doing it automatically for you. So
So
you don't have to worry about a lot of
I
stuff.
want to ask you, after you have made that guess and then you've gotten the values of P and B,
Mm.
are you going to maintain them as a constant?
Yeah, so now it depends on what you want to use it for. Yeah, yeah. Sometimes you want to always update it from time to time. Probably if you get some new data, you want to update it again and stuff like that. Right. So now this is what we are doing. So we are matching X to Y, and then I said you have answers, you have data, and then you have your rules. So the rules are the P and B values. We want to get those P and B values, right? So and then the input is the X, the target or the label or the answer is Y. So we say that the P and B values are called parameters. And then these are the parameters the machine learns, right? So first of all, how do we start it? As I said, you have to make a guess. And then once you design a system, right? The system, first of all, will have some default values. They are not correct values, but they are just default values. It starts with some value. So we say the parameters will be what? Initialized to some value, sometimes zero, but zero is not really good. So sometimes it just initialized to some random values, right? And then it starts from there. Once it starts from there, so it takes the data, looks through it, if it is correct or wrong, and then it will update itself, update several times, right? So now, if we are to do this, so let's say, first of all, we start by guessing P to be plus 3. Then we guess B to be what? Minus 1. So we have to now pass the X values through this PMB and then see how it performs and see the answers we get, right? So if you do that, what do we get? So here, if I pass my X through my So it means that if I have the equation will be y is equals to what? 3x minus 1, right? So I pass minus 1 through it and get an answer. I pass 0 through it and get an answer. Do that. So it means that those are the values I get. Those are the values I predicted. Then I have the real values also. So you see that I have my y is minus 4. If I pass minus 1 through it, you get what? Minus 4, right? If I pass 0 through it, I get minus 1. So those are my values, right? Now, the next is the real y. So you see that the real y is minus 3, minus 1, 1, 3, 5, 7. So you see that there's a difference between the real y and then my y. And then some are correct, right? Some are wrong. So now, based on this, you must calculate the accuracy and see whether it is good for you or not, right? So how do we now calculate the accuracy, right? So now, what we can do is that we can plot these values, the real y and then the y I guess. So you see that the blue dots are the real y, and then the green dots are the one I guess. So you see that it got one right, right?
Yes.
I think when
Yes.
x was 0, it got it right. So that one, there's no issue. So after you have done this, how can we get the differences? Very easy. Subtract the real y minus the predicted y. As easy as that, right? Once we subtract, we get some values. We get the first one will be minus 1. The second one will be so if the real y and then the predicted y are the same, it means that the once I do minus once I subtract the real y minus the one I predicted, it will be 0, right? So you see that for that one is 0 here.
Yes. Yes. That was very good.
So we have minus 1, 0, 1, 2, 3, 4. So now it means that if our number is close to 0, it means that we are on the right path. If the number is far away from 0, like 4, it means that we are far away. But our laws must be, we must combine our errors to see how the system have performed with the data we have. Right? So what we can do is that we can add all of this up to see the extent of our error, because the error will pass. So we will see to see if the error is huge or if the error is small or if they are close. So if the error is close to 0, it means that we are on the right path. If the error is far away from 0, then we have an issue. So we have to add all of this up. But if you add all of this up, you see that we have an issue. We have minus 1 and plus 1. They will cancel out. Minus 1 plus 1 is what? 0. So it will look like the system is performing well. So if you have, let's say, minus 1 plus 1 minus 1, it will all cancel out. It will be 0. And then it will indicate that my system has performed well, but it didn't actually perform well. So we need to do something about the minus 1 and the plus 1. What can we do about it? The minus 1 and plus 1.
Those ones will cancel out.
Now, so we need to eliminate
Okay.
the minus value. So how can we eliminate minus values?
By making one positive.
So how do you make one positive?
So how do we make
So we want to neglect or we want to eliminate this minus 1 plus 1 issue, right? Because we want all of them to add up. So we want to eliminate the minus 1 plus 1. So what can we do to eliminate that? Like, what, or in simple terms, what can we do to have all positive values so that we don't have an issue of minus 1 cancelling out some value? Understood? So what can we do?
can we here's a value again?
Oh, that from this value, so
Okay.
what if we square all the values?
The square.
The square of a negative number is what?
So we eliminate
The negative. So the square of a negative number becomes positive.
positive.
Like minus 1 squared is what? 1. So all we do is we have to just square them. And if we square them, we get 1, 0, 1, 4, 9, 16. So now with this, we have eliminated that negative issue. And then we can now add all of this. So this is the squared numbers. Then after that, we just add all of them up. Right? So if you add all of them up and now divide by the number, so we call it the mean error. Add all the squares up and then we divide by the number. I think the number is 6. We get 5.17. And then this is what we call the loss. And then the loss will indicate how well our system has performed or not. Understood? The loss. And then as I said, the loss will indicate how well our system has performed. So if it is far away from zero, the perfect loss is zero. That one, once it's zero, it means that our system has performed accurately, right? But in machine learning, we don't always get to the exact zero. It will always be 0.0090 or something. And then that will be good enough. But if the error is above one, then we have an issue. Once the error goes above one, like an error of 5.17, it means that our system is not really that accurate, right? So we need to do something about it again. So it means that once we get this error, we can actually guess, 5.17 is high. So it means that the values, the P and B values, what can I do to the P and B values to bring this error down? So that's where we now think again. And so do we increase the values or do we reduce the values? So you see that like once you get an error of this margin, it means that your values are too high. So you have to reduce the values. So now you have to make another guess. So this time the system is learning. It has learned that the values it gave it were too high. So the system itself will reduce those values, the P and B values. So you see that now you can give another guess of 2 and minus 2. And once you give P to B plus 2 and then B to B minus 2, we get differences of 1, 1, 1, 1. That's what you get if you go through it. Right? And then now, if you find the mean square error, so what we have done is we have found the mean square error. The mean square error. You know why it's called the mean square error? Because we squared it and then we took the mean. So that's why it's called the mean square error. So once we do this, once the P is plus 2, the B is minus 2, this is the value we get 1. Right? So now once we get 1, we know that we are very close to the value. We want a 0. So we are very, very close. So now we can make another guess again. It means that we need to reduce our value by a very small margin. So we maintain the P value to be 2 and then we reduce the B value to minus 1, right? And then we do the guess again, and then we calculate, and then once we do that, we get 0, 0, 0, 0, 0. Have you seen it already? And then once we find the mean square error of that 0, 0, 0, the value becomes 0. So it means that here our parameters are 2 and minus 1. Those are the accurate values, and then that's what the machine learning does. It does this to get those accurate values, and it uses that in the future to predict whatever we want. Understood?
But considering the mean square error,
Yeah.
should the difference always be squared? Or is
Oh
that
no, there are different forms of errors you can. There are different forms of errors you can use.
okay,
There are
okay.
different forms. They're just one form. So the mean square error is just one example of a way to calculate. And as I said, this is what we call the loss. One that calculation is called the loss. And then the goal of the mean square error is that we need to get a value that is as small as possible, close to 0 as possible. That's the main goal of the mean square error, right? So here I have I provided some collab for you to do. They, they, you guys go through it. I provided a notebook for that.
You didn't put it on the page.
It's on the page from yesterday or something like that.
From yesterday. I know it wasn't today.
Nah, yesterday.
No, maybe you posted it earlier.
Yeah, I posted it.
But I think Michael posted it from today.
Really. I said I will always post them a day to the. So if you check it, you will always see that they are updated.
Okay, you posted it this morning.
I see. So that notebook is trying to let you understand more on the law. Let me see whether I can. Let me see. So as I said, you can always use your Anaconda and then go into it and click on the Jupyter notebook, or if you have internet, you can use the Google Colab. But here I don't have internet, so I'll use the Anaconda.
Is that the mean square error?
Mm.
Should it be always, is it always zero or let's say about it?
Now it has to be close to zero, not exactly zero. In the machine learning, you can't always get exactly zero.
There should be less than one.
Hmm?
Should be less than one.
Yeah, so it's always
Like zero
around
point something.
0.00 something, 0.00, that kind of range. So, so if you open your Jupyter notebook, you just have to click on the environment to create it. I think I showed you how to do all this, right? You create an environment, so you click on that environment and click on there and launch there. Once you have installed it, you just launch it. And it will open a web interface for you, a web-like interface. And then you navigate to where your notebook is, and then so it will open a web-like interface for you like this, and then you navigate to where you stored that notebook. I think it's on my desktop. So exploring loss. Right, so this is yes it. Right, so the code are there for you to explore the laws and see how it works. So first of all, as I said, normally we want to be able to plot some stuff, right? Plot and see how our design works. So we use the what is called the mass plot. So you, as I said, in these are Python code. So you always import the library you want to use, right? So this is we are importing the matplot library. So you just click on the cell that you want to run and come in. Yes, you see run here. You just run it, and then there will be a star here. If there's a star here, it means that it's running. If there's no star, then it has finished running. Then our next is you see that we have our x and y values, right? So we define our x values, the minus one, zero, whatever, and then we define the y values also here. So we have to come and run this cell also, right? And our next is we just want to see the type of, and then it will be a list. Once you run this one, it will be a list, and then we plot it. We want to plot our y values, our x and y values, the actual y values, right? So we just use this the code here. You can go and sit down and understand the code yourself. So if I run it, so these are the x and y values. So we have plotted our you see our x here and then our y here. So these are the actual x and y values, right? And then next we can actually uh, our next is so we have to, as I said, you have to guess the W and B values. So just give W is equals to 3 and then B is equals to what? Minus 1. And then you run that cell. And then next is the next code. What it will do is that it will calculate the Y values, we want, right? Or we, so we have to pass. So you see here, within this code, we are looping through our x values. See, for xi in x, so we take one x value, we pass it through, take another x value and pass it through, and then we calculate our y values. That's all, right? And then after that, we plot the predicted values we got, and then this is what we get. So the blue line or the blue dots are for the blue dots are for the predicted values. The red line is for the actual value. Any issue? Any issue?
I don't know, it's good.
Huh?
No, no, we're trying to say what you're supposed to do.
Uh,
Okay, no do that. Okay, no see that. No problem.
so I said, so the red lines are the actual values, and then you can go home and go and try it on your own, right?
Okay.
Then I can print the length of it. Then I can use this code to calculate the mean square error, right? And then it will calculate the square error, which will be 31, and then we can use the next code to calculate the mean of the squared error, right? And then we get 5.17
Yeah,
as you
what
can
we
see
have
there.
earlier now.
Yeah, so now you can use this code, this code here, this long code here to do all we have done so far, like all from the top. So you just want it in one code, right? You can just use it. Once we run that, and then from there, if in case we want uh, we just come and say, so you see that the name of the code was, the name of the function was calculate plot error. Have you seen it in blue?
Yes, yes, yes.
Calculate.
Plot error,
So if I want to call it, I just come and say calculate plot error and give it the x values, the y values, and then the w and then the w and b. So here I'm using w to be 2, and then b to be what? -2. So once I do this, it will do everything for me, and then it will plot my predictions and then the actual value. So the blue line is the predicted values, the red line is the actual value. So I can continue to play with this thing and so on and so forth. But so here, what I can do is that I can fix one of the values of one of my parameters, probably the b, right? I can say let me fix b and now explore different values for the w and see how it works. So this code does that. So this code will calculate the mean square error for. So here we have different W's. W is -2, -1, 0, 1, 2, 3, up to 6. So but we have fixed B, right? If if we do that, this is what we get. So we can now see how each value works, right? How each W will work with. Yeah. And then from there, we can plot the mean square errors, the mean square errors we calculated against our W's, right? Once we plot that, this is what we get. Once we plot that, this is what we get. So you see that on the x-axis is the loss, that is the mean square error, and then on the y-axis is the W's that we used, right? So now we have fixed B, and then we are trying to calculate for different values of. So if W is -2, you see that the loss is on top there. The loss is very high, right? So now, imagine that the loss function, once you are plotting, will always look like this, right? So you, you, you see that our aim is that we need to get to a 0. That's where we are aiming at here. This value.
Now,
We want this, we want our mean square error to be 0. So it means that how do we get there is a main issue. So once we start with 80, right? Once we look at the top there, we started with 80. So how do we so if we get 80, so if we get 80 with there's a very simple formula that is being used, right? So first of all, I start with -2, right? As our W, and then I get the loss, a mean square root of 80.
80, yeah.
So now, once I get a mean square of 80, so how do I move? Do I move up or down?
Down.
So you say that we must move down, but we don't know by how much. We don't actually know by how much we must move down. So it means that this is our W0, the value we used. Now we need a new W1, right, to calculate another mean square error. That's what we are just doing basically. But how do we do this? So we say that W1 is equals to our W0,
Okay.
right, minus, there's a value called alpha, right? Then times alpha times the change in the loss over the change in W. You see this? So we can have, once we are able to, so if we see something like, if we see something like this, changing laws of a changing the is just the gradient. You guys know how to calculate gradient, right?
Yes.
If we see a line, then they have to calculate the gradient between 2 points. You know how to do it. The changing, like you have a plot like a plot,
Changing X over changing Y.
changing y over x over changing x, right? So this is just the gradient. So once we're able to calculate the gradient, we know the direction to move. We will know whether we are moving up or we are moving down, right? So, but by how much, but by how much should we move? That is this value, this alpha, right? So once we calculate the gradient, we will know we are moving down, but by how much? Are we moving down by 1 step, 2 step, 3 step? So that's the alpha value here,
So the
right?
alpha value have to guess.
Yeah, it is always okay. You will, let's see. Yeah. So what do we do here? So let's take 80 and minus 2. Our first, let's say our change in the loss was 80, and then our change in W was what? Minus 2, right? So 80 divided by minus 2 is what?
That is minus 1
So I get minus 4. So I get, let's say alpha into bracket minus what? 40 minus W0 was minus 2, right? Something like this, right? So now this value will indicate, as I said, how far we are going, right? So let's say I pick this value to be, let's say, 10. So now my aim is I'm finding my next W. That's my aim, but my next W must actually come down because our aim is we want to come to as close to zero as possible, right? Right? So if I choose, let's say alpha to be 10, what is the answer here? The W1 will be equal to what?
So that let's say maintain the limit. Then what will happen is that the thing will multiply the one in the bracket.
Yeah, yeah,
So
yeah, of
that
course.
becomes negative 400.
Mm-hmm.
Yeah. Then
Minus.
so that will be negative 402.
So this will be positive, right? Minus minus.
Yes, one man will be positive.
So
So
100 minus 2, so
398.
398.
Yes.
Now, once it means that I use 10,
Yes.
I get a value like 398. So if we check on the graph, 398 is not even near anywhere. So it means that we are lost, crap. And then we will have an issue. So this value is very, very important, right? So let's say I guess something like 0.005. What will be the value? Once I guess W, this is 0.05.
Okay, so 0.005 times 40. So that's 0.2.
Where?
Both. The 0 times the 40 is 0.2.
So it's minus
So that will
plus 0.2
be, yeah. So,
minus 2
so the whole thing will be minus 1.8.
minus 1.8.
Yes, sir.
So you see that it means that this one, we have to use a learning rate of 0.005. It tells me that I must move down by minus, so I will move here. My next will be around here, right? And then it is good enough. It means that I can find the next one will come down again. The next one will come down again. The next one will come down again. So this alpha is what is known as the learning rate. The learning rate, yeah. What is important about it is that, and it is very important in the machine learning and then it's very important in machine learning because it will now, if you choose a learning rate that is very, very small, like something like this, it's good, right? It's good because it will always be coming down, coming down, coming down. But it will, it will be coming down so slowly. So it means that you will have to train, then it will come down small, small. So once you choose a learning rate of very, very, very small, it's actually good, but it might take you the whole day before you can get to the person. Right? Now, if you choose, as you saw, if you choose a learning rate of a very high learning rate, it will just be jumping about, just giving you some huge values that it don't even, sometimes it don't even be within the graphs, right? So it will never get to zero. It will go from here to another huge value, another huge value, another huge value. So the learning rate is very, very important. But in it's very, very important in machine learning. That's
So, sir, since when you choose the learning rate, when you choose a smaller number,
yeah, yeah,
this should take you a longer period for you to complete
yeah, yeah, yeah.
the learning. Don't you think that one is better than choosing the older number?
So it means that you need to optimize. So in machine learning, the longer you are taking, the more power you are consuming. So you need to choose a learning rate that will converge faster, will get to the zero, or will get to that bottom line faster. But it will it should not also overshoot. We call it overshooting. Sometimes it will just overshoot and go to another place, and then it will go to another. So that one is bad. So it means that you need to always be careful. Sometimes they just always fix it that once you're using, they always fix it around this value 0.005. That's always almost the optimum value for the learning rate, right?
Yes, sir.
So I think this next one talks about the learning rate, and as I said, the graph always looks like this. So this graph is what is called the loss function, and our aim is to always get to the bottom, right? So we always start from somewhere, always. If we start from somewhere, then we always move to the bottom, right? And then we move in the direction of the gradient. We calculate the gradient, and then the gradient would tell us how to move up or down, right? And then, as I said, so this is the formula they use. W1 is equal to W0, said over here. And then we have to move by some steps. The steps is what I said is the learning rate, right? So you move step by step by step. So now the issue is if the learning rate is too small, as I said again, it will take a long time to get to the bottom. Now, if the learning rate is too high, you might be doing something like this. Just going from here to here to here to here, and then it will just become, it will just loop, go from here to here, then it will never converge at the bottom. Understood? Right. So here, as I said, in machine learning, we make a guess, measure the accuracy, and then we optimize our guess, and then we repeat. So what are we guessing? As I said, we are guessing the W and B's, right? So W, I, and then B. And then I think the last time I said in machine learning, we have something called the weights, and then the bias. So what we're always guessing are the weights and the biases, the W's and then the B's, the weight and biases. So the weight and biases are just called the parameters, right? And then we always measure our accuracy. We use the mean square error to measure our accuracy, and then we optimize our guess by changing the learning rate, and then we go on again. So we have something also called epoch. The epoch is the number of times we run the algorithm. As easy as that, right? Okay, so this is the first one. We are done with the first one.
So,
Any question
it
here?
will continue to run until you finally get the maybe zero for it.
So now you saw here we have the epoch. So you give it a value. Probably you say run for two one run for like two times, and then it will just do it twice and just give you your accuracy. And then if you're okay with it, fine. And then if you say run for 1,000 times, it will run for 1,000 times. So that's the epoch. Any question?